Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are starting our fifth chapter from NCERT book, which is Arithmetic Progressions. This is the introductory video in which we will be dealing with the basic concepts, formulae of this chapter. Moreover, we will practice few questions based on those concepts. Now, this is a new topic for class 10, which is arithmetic progressions. What is this AP known as? It is a sequence of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. See, let's say the first number is given to you. If I keep adding a particular number to this, like if I keep adding 3 to every preceding number, if I add 3, it becomes 5. If I add 3, it becomes 8. If I add 3, the next number comes out to be 11. So similarly, if I keep on adding a particular number to the previous number, I will get a sequence or a list of numbers, and this list of numbers is called arithmetic progression. So this condition doesn't hold true for the first term because first term is not bound by anything. But if we have first term and we keep on adding a particular number to every preceding term, we will get this sequence. And such sequences are called arithmetic progressions. Right? And the fixed number is called the common difference of AP. This fixed number that we are adding, right? I am adding 3 here to every number. So this fixed number is called the common difference. And this is the first term of this sequence. The first term of sequence is always represented by A. And this common difference, a number which is getting added to every term, is called the common difference, which is represented by small d. So there are two important terms in every AP. If we know A and D, we can solve the whole AP. We can find any value of this AP. So apart from the first number, every number is the sum of the previous number plus common difference. Common difference is D. And one important thing, this common difference can be a positive number. It can be a positive number, it can be a negative number, or it can be 0 also. So let us have few examples. Just to simplify this language thing, we can write that A plus D, A plus 2D and A plus 3D represents an arithmetic progression where A is the first term, A is the first term. Now keep on adding 1D to the previous. Like if I add D to this, I will get A plus D. If I add another D to this existing A plus D, it becomes A plus 2D, which is the next number. Now this is the existing number. If I add 1D to it, it becomes A plus 3D and so on. So this is a particular pattern, a general pattern you can say. This is a general pattern in which arithmetic progressions move. So A plus D, A plus 2D, A plus 3D represents an arithmetic progression where A is the first term and D is the common difference. This is called the general form of an AP, right? Now we are going to do some examples to check how can we say whether a sequence is an AP or not. This is the first term, A here. A is -7. This is A1, first term. A1 or A are the same things. This is A2, second term. And this is, you can see that what is getting added so that we get -7 becomes -9. So you can see -7 minus 2 is -9. That means if I add -2 to the previous number, first term, I get the second term as -9. Now again, if I add -2 minus 9, minus 2, minus 11. Similarly, if I add minus 2 to minus 11, minus 11 minus 2 becomes minus 13. So this is an example of AP in which common difference D is negative 2 and the first term A is negative 7. Right? Similarly, in the next examples, here the first term is 0. A is 0. Now what should be added to this to get? This is 1.5. So 0 added to 1.5. Here D automatically becomes 1.5, or you can say it is 3 by 2. Now if you add 1.5, 0 plus 1.5 is 1.5. 1.5 added to 1.5. 3 by 2 added to 3 by 2. 3 by 2 added to 3 by 2 is 6 by 2, that is 3. So here also D is 1.5. 3 added to 1.5 makes it 4.5. And 4.5 added to 1.5 makes it 6. So here also this is an AP with the first term is 0 and common difference is 1.5. Right. Next is here you can see that your common difference is negative. In the second case, your common difference values of D can be negative, can be positive, or it can be 0. So this one is 6, 9. First term is A, here is 6. What should I add here to get 9? It is plus 3. 9 added to plus 3 becomes 12. 12 added to plus 3 becomes 15. So in this case, first term is 6 and common difference is plus 3. Right? Next is 2, 2, 2. Here your first term is 2 and you can see that what should be added to 2 to get 2? It is 0. What should be added to get another 2? It is 0. So here common difference is 0. Still this is called an AP. So the value of D can be 0. It can be positive. It can be in positive fraction or negative fraction, and it can be a negative number. All these are the examples of arithmetic progressions. Next is for the AP, given AP 3 by 2, 1 by 2, write the first term A and the common difference D. So now how do we solve this? Because every time we cannot add orally to something to get the next number, so we should know the proper method to find the common difference. See, this is the first term. Your A is 3 by 2. Instead of looking for this, what should be added to get this? You can say that difference of the two consecutive terms should be same. This is your A1, this is your A2, this is your A3 and A4. That means first term, second term, third term and fourth term. Terms of an AP are represented by small a with subscript 1, 2, 3, 4 respectively. First term is A1. So if I have to find what number has been added to 3 by 2 to get 1 by 2, the common difference becomes 1 by 2 minus 3 by 2. That is equal to minus 2 by 2. That is negative 1. So if this sequence is an AP, it is given that this is an AP. You have to find D. You should always solve A2 minus A1. Take the difference of two consecutive terms, any two consecutive terms. Second minus first, or third minus second, or fourth minus third. So you can take the difference of any two consecutive terms. That is called the common difference. A2 minus A1 here is negative 1. You can see here A3 minus A2. A3 is minus 1 minus A2, which is half. So we have minus 1 by 2 minus 1 by 2 is minus 2 by 2, which is minus 1. So if it is already given that this is an AP, so the difference between any two consecutive terms remain same throughout the sequence, right? A here is 3 by 2 and common difference D here is -1. So we have found both the things. Next is, which of the following list of numbers form an AP? If they form an AP, write next two terms. So here, first of all, we have to check whether the list of numbers or sequence forms an AP or not. For that, look for the first term, write this as your first term. And then if you have to check, I have told you, if this is an AP, then the difference between any two consecutive term will be same. So check for A2 minus A1. 10 minus 4, that is 6. Check for A3 minus A2. This is 16 minus 10, also 6. So finally we have A4 minus A3, 22 minus 16, which is also 6. So you can say that the difference between all two consecutive terms is constant. So we can say that this is an AP, arithmetic progression, right? In the second part, we have A is equal to -2. A1 is this, A2 is 2. So find A2 minus A1. That is 2 minus -2. So we have 2 plus 2, that is 4. Next find A3 minus A2. A3 is -2 minus 2. This is your A3 minus 2, and if you subtract 2 from it, this is -2 minus 2, which is -2 minus 2, which is -4. So you can see that here the common difference, the difference of two consecutive terms is 4, and in this case the difference between two consecutive terms comes out to be -4. So the value of this difference is not equal to this difference. So we can say that this sequence is not an AP. This is very easy and important question to check whether a sequence is an AP or not. You simply have to take whatever numbers are given to you. There will always be 3 or 4 terms given in the question. So you have to check the difference between two consecutive terms in given 2 or 3 pairs. If they are equal, this forms an AP. If they are not equal, this is not an AP. So the next is nth term of an AP. Now a sequence is generally a large set of numbers. So we have learned that the general form of an AP is given by A plus D, A plus 2D, and so on, right? So how do we calculate the further terms? The first term is A1 is represented by A. Second term becomes, if you add D to the existing first term, it becomes A plus D. So A2 is equal to A plus D. If there is already a first number given to you, add D, so you get A plus D. Now add D to the existing number, A plus D becomes A plus 2D, right? This is A plus D, which is A plus 2D. Now if you add, this is your second term, A plus 2D, add another D to this. So this becomes A plus 2D plus D, which becomes A plus 3D. So this is the sequence, right? A4 is A3 plus D, add D to the third term. A3 is A plus 2D plus D, it becomes A plus 3D. Now 3D means, now here you have to make a pattern. So what we do is, we write A1 is equal to A, A2 is equal to A plus 1D. You can see that if we are finding the second term, the coefficient of D is 1, right? That means 1 less than the number of term. See the format here. Second term is a plus 1d. That means only 1 less d is added to what is the number of the term. Then in the third term, the coefficient of d becomes a plus 2d. That means it is 1 less than the number of term. Here also this is a4. So that means a4 is equal to a plus 3d. If you can see the number of term is 4 and the coefficient of d is 1 less than. So this pattern has been maintained throughout. Whatever the number of term is, the coefficient of d in that case is 1 less than the number of term. So if we maintain this pattern, we can say that any number of term if we have to find, let's say random d, if we are finding 25th term, that means it should be 25 minus 1d. That means it should be a plus 24d. So this is the pattern. This is the pattern. So by generalizing this thing, we can say that any number of term, general term is given by nth term. Any number of term is equal to the first term added to one less number multiplied by d. That means if we are finding 100th number, 100th term, then 100th term is given by first term added to 99 times d. Coefficient of d is 1 less than the number of term. So an is called the general term of an AP. You can find if a pattern is given, a and d are given. I told you in the beginning that if a and d are given or known to you, you can find any number of term in an AP. So this was the formula for the general term or nth term, you can say nth term of an AP. Next we have to find the 10th term of the given sequence 2, 7, 12 and so on. So first of all you can check the difference between 7 and 2 is 5. Difference between 12 and 7 is 5. So this is an AP, though it is already given in the question. So looking at this AP, first term is 2 here and A2 minus A1 is 7 minus 2, that is 5. So common difference is 5. These are the two basic terms to solve any AP. Here we have to find the 10th term. In the last slide we had learned that the formula for the nth term, any number of term, is a plus n minus 1 d. A means the first term, which is 2. N here is, since we have to find 10th term, we have to find 10th term. That is, n means number of terms. So 10th term becomes first term plus 10 minus 1 times d. D here is 5. So 2 plus 9 times 5, that is 2 plus 45, which is 47. Right? Now the next question says, which term of the AP 21, 18, 15 is negative 81? So in this case, you have to find the term or the number of term at which minus 81 exists in this sequence, right? So you're looking at this AP, we can say that the first term is 21. And for D, I'm taking the difference of two consecutive terms. It is 18 minus 21. This is negative 3. So the value of D is negative 3. A is 21 and D is minus 3. What you have to find here is at which number. That means the term of the number where we have minus 81 as the value. So that means the value of nth term is given to you, which is negative 81. And we have to find this n, at which number this number is existing in this sequence. So there is nothing different in this case. You have to use the same formula. An is a plus n minus 1 d. The only difference is instead of finding an here, an is given. An is equal to a plus n minus 1 d. Here your an is negative 81. And then first term is 21 plus n you have to find. And d here is negative 3. So now we simplify this. This is negative 81, 21. You open this bracket. Negative 3n and positive 3. So negative 81, here we have 21 plus 3 is 24 minus 3n. So 81, this is negative 24 and negative 3n. This becomes minus 105 and this negative 3 comes here in division. So the value of n becomes 3 3s are 9. That means this term negative 81 will be there in this sequence at 35th number. So the value of an is negative 81 and the number of term is 35th term, right? So you can write a 35 is minus 81. That means at 35th number the value of the sequence is minus 81. The next part says also, is there any term 0? This is the sequence given to you and you have to check whether any term can be 0 in this sequence. If yes, we have to look for the term. An is a plus n minus 1d is equal to 0. A is 21 and n we have to find. D is negative 3. This becomes 21 minus 3n and plus 3 is equal to 0. What we can do is 21 plus 3 is 24 minus 3n is 0. So 3n becomes 24. So n is 8. That means yes, there we can have 0 as one of the terms of this sequence. And the number of that term will be 8th term. That means 8th term of this sequence, 8th term will be 0. Right? Next is check whether 301 is a term of the list of numbers. Here the sequence is 5, 11, 17 and 23 onwards. First term is 5 and then a2 minus a1 is 11 minus 5, that is 6. So the common difference is 6 and first term is 5. We have to check whether 301 exists in this sequence or not. So that means we have to fix our an as 301. An is 301. So the formula remains same. The value of an is a plus n minus 1 d. The value of an here is 301. First term is 5 and we have to find, and then d is 6. D is 6. 3051 is equal to 5 plus 6n minus 6. Now simplify this. This is 5 minus 6 is minus 1. So this becomes 302 divided by, this is plus 6. This is n. Now this number is not perfectly divisible. 2 3s are 2, 151. Right? Now if I take it in fractions, or you can say if you divide 150, this is 53s are 150 and 1. The value of n is in fractions. value of n is coming in fractions, and we cannot have the number of term in fractions. This n denotes the number of term. Number of terms can be 1, 2, 3, 4 in the positive integers. It cannot be in fractions. So we can say that there is no term whose value is equal to 301. So 301 is not a term of the given A. Now the next question is, how many two-digit numbers are divisible by 3? So first of all, here we have to form a sequence of numbers which are two-digit numbers as well as their multiple of 3. So the very first two-digit number is 10. But you can see this is not a multiple of 3. So you go for 11. It is also not. 12 is the first number which is a multiple of 3. Now since the sequences of all the two-digit numbers which are multiples of 3, that means the consecutive number will be again a multiple of 3 immediately next to 12. So keep on adding 3 to get the sequence, because all the numbers have to be two-digit numbers with divisibility of 3. This is the sequence. You have to calculate, or you have to find a sequence in where the last member of the sequence is also a two-digit number, but it is a multiple of 3. Last two-digit number is 99. So you have to check whether it is a multiple of 3 or not. Yes, it is. Divisibility of 3 is 9 plus 9, 18. 18 is divisible by 3. So 99 is divisible by 3. Now the sequence is this. And we also know the last member of the sequence. What we have to calculate is how many two-digit numbers are there. That means we have formed this sequence and we have got the first term, common difference, and the last term of the sequence. So this is the general term. You can say we don't know at which number this 99 will appear in the sequence. So we have to find how many numbers are there. That means what is the count at which this 99 is occurring in the sequence. First term is 12. Common difference is 3. And an is 99. That means you have to find n in this case. N, that is the number of terms where this 99 exists in the sequence. So use the same formula. An is a plus n minus 1 d. The value of term is 99. First term is 12. N we have to find the number of the term at which number we have 99. D is 3. So 99 is equal to 12 plus 3n minus 3. This is equal to 99. 12 minus 3 is 9 plus 3n. So we have 99 minus 9 is 3n. The value of n is 90 minus this 30. Right? That means this is A30. 99, the value of 99 comes at 30th number in this sequence. That means we have 30 numbers in all in this sequence, because the last term is 99 here, and 99 is the last term. That means number of terms in total are 30. So this sequence has got 30 terms. Next is, after dealing with the nth term, general term, now we have another topic in this chapter, which is the sum of n terms of an AP. Right? Now we know that if we have an arithmetic progression with the first term A and the common difference D, so the value of sum of these terms or the sequence is given by n by 2. N is the number of terms. A is the first term and D is the common difference. So if we know A and D of an AP. If we know A and D of an AP, we can find a sequence. And if the sequence is known and we are given that, find the value of 10 terms of that sequence or 15 terms, that means n is also given. So we can calculate the sum of those terms. This is the formula that you have to find sum of n terms. In case your last term is not known, right? Now, if there is a special case, that means you can break this 2a into a plus n minus 1d. Write this 2a as a plus a, and then we have n minus 1d. See here carefully, if you drop this a, this value is a plus n minus 1d, and we know that the value of a plus n minus 1d is nothing but an. That means general term, nth term. So what we do is I am replacing this a plus n minus 1d by a, right? An. So an means if an is the last term, if an is the last term of the sequence, there are n terms in a sequence. In that case, this an can be replaced by L. L is the last term. So if the last term of the sequence is known, this is the first term, this is the first term, and L denotes the last term of the sequence, and n is how many terms are there in the sequence. Then we can calculate the sum in this way also. So yes. Now the next question says find the sum of first n positive integers. So here we have to make a formula from the particular thing. Like we have to find the sum of first n positive integers. So we start with 1, 2, 3, 4, 5 onwards. So if we have n terms starting from 1, this is 1 stands for first term, 2 stands for second term, 3 stands for third term. So we have an as nth term. So value of an will be n itself because we are starting with 1. So in count, number of terms is n, and the last term here, since we have n terms and the common difference here, first of all, common difference is 2 minus 1, that is 1, right? Fifth term stands for 5. Sixth term, this is fifth term, A1, A2, A3, A4, A5. A5 stands for 5, A6 stands for 6, that is why AN stands for n. The value of nth term is n itself. And since this is the last term, we can say that last term is n. Now find the sum. The value of sum is n by 2. Since the last term here is known to you, we can use this formula, the second one. If the last term is known, we can easily use this formula. This becomes n by 2. Number of terms here is n. This is first term here is 1 and last term here is n. An is n. So the formula becomes n by 2 n plus 1, right? Sn. Sum of n positive integers. Starting from 1, it is n plus 1 by 2. So I have simply used the formula that we had learned in the last slide, that if the last term is known, we can find the sum of the sequence, sum of n terms of the sequence by using this formula where L is the last term. I have just substituted the values here. Next question is, find the sum of first 24 terms of the list of numbers whose nth term is given as, this is very interesting question, 3 plus 2n. Generally sequences are represented by general terms. That means we can develop a sequence by putting different values of n here and here. So A1 stands for the first term, value of n becomes 1. So you have to create the sequence first, that is 5. A2 becomes 3 plus 2 multiplied by 2. 3 plus 4, that is 7. 3 plus 2 times 3. This is 3 plus 6, which is 9. So developing this, we have 5, 7, 9, 11 and so on. Right? So first of all, we have formed the sequence. Now he says find the sum of first 24 terms. So n here is 24. Looking for the sum of 24 terms, we are just restricted our n to be 24. Now look at this sequence. First term is 5 and common difference here is 7 minus 5 is 2. This is 2. We have got a and d, so we can find any number of terms. And if we know the value of n, we can find sum also. So here you have to find Sn. Formula of Sn is n by 2, 2a plus n minus 1 d. Here the last term is not known. See, the sequence is infinite sequence. We can keep on finding terms. We just have to restrict ourselves to 24 terms. We have to find the sum up to 24 terms. That means the last term is not known. So I am using this formula. S24 is, n here is 24, 2 times a, which is 5, 24 minus 1 times d. So we have S24 as, you can divide this 24 by 2, multiplied by 2 5s are 10. This is 23, 23 times 2. This is 12, 10 plus 46, which is 12 multiplied by 56. So you can get 56, 12. This is 56. 672. 672 is the sum of first 24 terms of this sequence. Right? This is how we use this formula. So this was all about the formulae and concepts of this chapter. We have learned how to do basic questions in this video, and in the next video we will be starting the exercises of NCERT book. I hope the concepts are clear and you liked watching this video. Please like, subscribe and share it with your friends. Thank you.